Welcome, everyone. Today, we are going to master how to configure and manage built-in and custom Microsoft Entra roles. As you move toward a zero-trust security model, how you govern administrative access is critical. Let's dive right in and transform how you handle privileged identities. Let's begin by defining exactly what we are managing. When we talk about Microsoft Entra roles, we are talking about permissions that control access to your directory resources, things like users, groups, and application registrations. A common pitfall I see is confusing Microsoft Entra roles with Azure roles. Remember this distinction: Entra roles manage your identity platform via the Microsoft Graph API, while Azure roles manage your Azure infrastructure like VMs and databases via Azure Resource Manager. Why does this matter? It is a fundamental security boundary. A compromise in your Azure infrastructure should not automatically mean a compromise of your identity system. As we configure these roles, we will be assigning them at various scopes, which could be your entire tenant, a specific administrative unit, or even just a single application. By understanding this separation, you set the foundation for a robust, zero-trust architecture. Take a look at the diagram on your screen. At the top, we establish the core separation between identity and infrastructure. On the left path, we see Microsoft Entra roles. Notice how their scope operates at the tenant, administrative unit, or application level, and they strictly manage identity resources like users and groups. On the right path, Azure roles operate at the subscription or resource group level to manage infrastructure like virtual machines. Keeping this visual separation in mind will guide every role assignment decision you make moving forward. Now that we know the landscape, let's look at the tools already in your toolbox: built-in roles. Microsoft provides over 60 of these out-of-the-box roles, and their permissions are fixed. You can categorize them easily. Some are specific to Entra ID, like the user administrator. Others are service-specific, granting access to workloads like Intune or Exchange. And finally, cross-service roles like security administrator or global administrator. The beauty of built-in roles is that they are ready to use immediately and do not require premium licensing. However, I must stress a critical security best practice here: you must strictly limit your highly privileged roles. Microsoft recommends having fewer than 5 global administrators. If you have 20 global admins, your attack surface is massive. Always ask yourself if a user truly needs global admin, or if a more scoped built-in role, like an application administrator, would suffice for their daily tasks. This hierarchy diagram illustrates the blast radius of different built-in roles. At the top, the Global Administrator and Security Administrator roles have sweeping access across both Microsoft Entra ID and all Microsoft 365 services. This is why they are highlighted as high risk. Below them, you see roles like User Administrator and Application Administrator, which are confined strictly to Entra ID resources. On the right, service-specific roles like Exchange and Intune administrators are confined to their respective workloads. When assigning roles, always aim for the lowest block on this diagram that still allows the user to do their job. We cannot talk about identity without discussing the principle of least privilege. In identity governance, this means granting administrators exactly the permissions they need, over a very specific scope, and ideally, only for the specific time they need it. It is tempting to just assign a broad role at the tenant level because it is convenient, but you must resist that urge. By strictly limiting roles and scopes, you drastically minimize the blast radius of a cyber attack. If an attacker compromises a helpdesk administrator, you want their access limited to resetting passwords for a specific department, not the entire global enterprise. How do we do this? We use administrative units. By assigning a role at the scope of an administrative unit, that administrator can only manage users within that unit, and they are completely blocked from changing tenant-wide configurations. This is a massive win for your security posture. This flowchart represents the decision-making process for least privilege. When you identify a task a user needs to perform, first ask, does a built-in role exist that can be scoped down? If yes, you assign it at the administrative unit or resource scope, achieving least privilege. If no built-in role fits perfectly, you move to the right side of the diagram. You create a custom role with exact permissions and assign that at a restricted scope. Following this flow ensures you never hand out tenant-wide keys unnecessarily. What happens when the 60+ built-in roles don't meet your exact business needs? That is where custom roles come in. Custom roles allow you to cherry-pick exact permissions from a preset list to build a role tailored perfectly to a specific job function. The process is twofold. First, you create the role definition, defining what can be done. Second, you create the assignment, defining who can do it and where. A great example is application management. The built-in application developer role limits users to creating 250 objects to protect directory quotas. If you have a senior DevOps engineer who needs to create unlimited app registrations, you shouldn't make them a global admin. Instead, you create a custom role with just the Microsoft.directory/applications/create permission. Keep in mind, leveraging custom roles is a premium feature and requires an Entra ID P1 or P2 license for the assigned users. Let's look at the programmatic structure of custom roles in this class diagram. On the left, we have the custom role definition, which contains the name, description, and the exact list of granular permissions. This definition is a static template. On the right is the role assignment. You take that one template and you can assign it many times, linking it to different security principles like users or groups at different scopes. This separation of definition and assignment makes custom roles incredibly scalable. Assigning roles to individual users works for a startup, but at an enterprise scale, it becomes a management nightmare. The solution is assigning roles to groups. Instead of tracking 50 individual help desk admins, you assign the role to a help desk security group. When an employee is hired, they are added to the group and inherit the permissions. When they leave, you remove them from the group, and the permissions are instantly revoked. However, because giving someone access to this group effectively grants them an admin role, Microsoft Entra treats these groups differently. You must explicitly create a group as a role-assignable group by setting a specific property during creation. Once created, Entra locks down the group. Only highly privileged admins or the designated group owner can modify its membership. This prevents a lower-level admin from sneaking their own account into a group that holds security administrator privileges. This flow visually demonstrates the security of role-assignable groups. A new employee is added to the group in the center. Because that group was created with the isAssignable to role property set to true, it can hold the security admin role, granting the employee access. Crucially, look at the bottom left. An unauthorized administrator is blocked from modifying this group. Entra's built-in protections ensure that only the right people can manipulate who gets these elevated privileges. Even with least privilege and group assignments, having standing administrative access meaning the permissions are active July 24th is a massive risk. This is where privileged identity management, or PIM, becomes your best friend. PIM shifts your model from persistent access to just-in-time access. Instead of making a user an active administrator, you make them eligible. When they need to perform a task, they must go into the portal and activate the role. You can configure PIM to require them to perform multi-factor authentication, provide a ticketing system justification, and even require approval from another manager before the role turns on. After a set period, say 4 hours, the role automatically deactivates. For extreme security, PIM can even integrate with conditional access to ensure the user is activating the role from a compliant, corporate-managed device. This state diagram walks through the PIM lifecycle. The user starts in the eligible state. They have no elevated permissions yet. When they need to work, they request activation. The system immediately enforces policies, asking for MFA and a written justification. If an approval workflow is configured, it pauses in pending approval. Once approved, the user enters the active state and can do their job. Finally, once the timer runs out, the system automatically drops them back to the safe eligible state. No standing access is left behind. Let's apply everything we have learned to a real-world scenario. Imagine your company just acquired another firm, and overnight, your IT help desk expands by 50 new technicians. They need to reset passwords. If you grant 50 people permanent help desk admin rights across your entire global tenant, your security team will rightly panic. The attack surface is too large. Here is how we use our tools to solve this. First, we create an administrative unit specifically containing the employees of the acquired company. Second, we create a role-assignable group for the 50 new technicians. Third, we use PIM to assign the help desk admin role to that group as eligible, but we scope that assignment strictly to the new administrative unit. The result, 50 technicians have zero standing access. When they need to work, they activate via PIM using MFA, and they can absolutely only reset passwords for their specific subset of users. You have achieved security, compliance, and operational efficiency. In this final architectural diagram, you see the brilliant synergy of these features. The 50 techs enter the role-assignable group. Through PIM, they become eligible for the help desk admin role. But look at the routing. That role scope is forced through an administrative unit, pointing only to the acquired company users. Access to the broader tenant root and global users is firmly denied by the system architecture. This is zero trust identity governance in action. To wrap up our training, we must look at maintenance. Security is not a set it and forget it deployment. People change departments, projects end, and over time, users amass access they no longer need, a phenomenon known as permission creep. To combat this, we use Microsoft Entra access reviews. Access reviews allow you to enforce periodic audits of who holds what roles. You can configure a review targeting your PIM Microsoft Entra roles, asking the administrators or their managers to attest that they still require the access. What makes this truly powerful is the automation. You can configure the review so that if a user fails to respond within the review period, the system will automatically strip their eligible role assignment from them. By combining built-in and custom roles, scoped properly with administrative units, secured just-in-time via PIM, and continually audited via access reviews, you ensure a resilient, zero-trust environment. This diagram illustrates the automated lifecycle of an access review. The review begins and notifies the designated reviewers. They are faced with a simple question: do you still need this role? If they approve, access is maintained. If they deny it, access is instantly revoked. But the most crucial path is at the bottom. If there is no response, the system's auto-apply feature defaults to revoking the access. This failsafe ensures your environment cleans itself of dormant permissions.